Hi, so today we'll look at another supervised machine learning project, which is advertisement click prediction. This project is a very simple one. We'll be using IBM Watson services over here. So the backend is entirely dependent on IBM Cloud. So what does this project actually say is it predicts whether the user is likely to view an advertisement or not. So on screen we'll be having, or on at phone we'll be having, or on laptops we'll be having a lot of advertisements which are being hosted on various websites, right? So is user gonna likely to watch that ad or not? That kind of prediction we are gonna make using this project. So let's look at the overview of it. So as I mentioned that we would be using the IBM Watson service. So we have to log in into IBM Cloud, and then we have to create an Watson Studio instance. Then we have to load the data. The data set would be provided in the code files, and we have to create the machine learning instance for learning. Then after we create the machine learning instance, we will have to create the algorithm pipeline on Watson Studio, and then promote the best algorithm to the deployment space. That means we have to deploy our machine learning model. Once the machine learning model is deployed, we would have to get the API key and then integrate the code with the UI, and then after integrating the code with the UI, we have to deploy our entire application on Heroku cloud. So seems like a little bit complicated in the workflow, but when you watch the other videos which are coming next, it would be crystal clear, I'm sure for it. Just sit back, relax, and watch all the videos in a flow. You'll understand everything, and I'm damn sure that you will work on more projects using IBM Watson Studio. Sit back, relax. Thank you. Hi. So today we'll be discussing about another project using IBM Watson. So this project is about advertisement prediction, which based on the data set says whether the user is more likely to click on the advertisement or not, based on several factors, and those factors are like the daily time, the age of the user, the area income, the daily internet usage of the user, the advertisement topic line. It also depends on whether the advertisement topic line is trendy, or advertisement topic line is like a little bit fade or is in buzz, anything. So that kind of topic line, then the city where the user is residing into, and then the gender of the user, the country name, and then the timestamp when the user is about to watch the video or the advertisement. So based on several factors, we have to predict whether the user is more likely to watch or click the advertisement or not. So I have already made this, and then I wrote this streamlit run app.py. This is a Streamlit application, and then it has opened it, and the end result is something like this over here. So I have entered this daily time to be 68.95 minutes, and age is 35, area of the income is this, daily internet use is 256.09, closed, and the advertisement topic line is cloned 5th generation orchestron, and city is Weidberg, gender is female, it can be either male or female, and then country name is Tunisia, and then timestamp is this, and then when I hit on predict, this takes a little bit time, and then based on the above factors, the user did not view the advertisement. So simple supervised machine learning project, short and simple deployable machine learning project, which is made using IBM Watson. So we can see over here API key, ML token, and header. This everything is from the Watson service, and over here also. Payload scoring and response scoring is also from IBM Watson. This whole part is basically from IBM Watson thing only. So this makes our thing a little bit simple by using IBM Watson. And if you want to look at the description of the dataset, here is the description of the dataset. You can just hit on here and then we can get the description of the dataset. The consumer time on site in minutes, the customer age, the average income of geographical area of consumer, average minutes of day, the consumer is using the internet, the headline of the advertisement, city of the consumer, and everything. So this is a brief description about the data set, and then these are the steps which I have mentioned which I have mentioned where we have to set up the IBM cloud service. So these description files will also be shared. So this was just a preview of the project. So this project we're gonna build, and we'll be using IBM Watson for this. So if you are having an IBM account, just simply log into your IBM account, hit your password, and then continue. If you're not having it, just click on create account and just create an IBM account. It's free, developed for free, no credit card required, as they said. Just write your information, write your verify email, just personal information, and then create account. It's very simple. If you get any kind of charges over here, then open this ibmcloud.ibm.com in an incognito mode, and then you will be free of all the charges and everything. It's better to open your ibmcloud.ibm.com in incognito and then register if you're new. But if you're already registered, then simply enter your credentials and hit enter. See you soon in the next video. Hello. So I hope everyone have registered on their IBM Cloud accounts. If not, just simply create. If you are new to IBM Cloud, then you can create your account on this page, icloud.ibm.com/registration, and enter your details and then hit create account. There will be a verification link sent on the email. Just click on it and your account will be verified. If you already have the account, just simply hit on login button, and then you will be redirected to a login page where you have to enter your credentials, basically your email ID and the password, and then hit continue. So you'll be redirected to the catalog page, and the catalog page would look something like this. So once if you're into this, so we'll start off with just searching on IBM Watson. So we will type in Watson. Just if we type Watson, we'll get the Watson Studio service. Just we'll hit on Watson Studio, and we would be creating a Watson Studio instance for our project. So we'll click on I have read and agree to the following license agreement, and then we'll hit create. So once we hit create, it will create an instance of the Watson Studio. Then we'll say get started. So we'll be redirected to a new page now where we have to do all our authentication tasks. Okay, so if you are new on this IBM Watson service, then there will be some kind of things which will be asked. You just need to select all the things and then simply hit enter. It's very easy to do that. So now we will hit on create a project, and this will redirect us to the project page, and then we will hit on create an empty project, and we'll give a project name for it. We'll say add classification to keep things simple, no complicated things. And then over here storage is cloud object storage demo, so it's by default included. If it is not included in your case, then they will mention here please create an instance of cloud object storage demo. Just hit on that, and just you will be redirected to another page where you have to hit yes. So when you hit yes, an instance of this will be created, and you will be seen a reload button over here. So if you hit on that reload button, this object would be created, and then you hit on create. So once if you hit on create, this will create your project, and now we will have to import our dataset from the local machine, and we are all set once the dataset is uploaded. Yep, so it's taking a little bit of time. Let it take, and then hit on add to project, then hit on data, and then just click on browse for files to upload. Then I'm using the advertising.csv. All the files will be provided in the project file or project folder. Please download from it, advertising.csv. So upload successful. Just go to assets and then click on advertising.csv in order to check for the data. It will take a little bit time because the data set is a little bit big. And here we go, we have the data set, and we would go for add classification now, and this is our entire thing. Now what we need to do is we need to click on add to project and then initiate the auto AI experiment now. So here also we will be writing the name, add classification ML, and then here they are asking us to associate a machine learning service instance. Just simply click on it, and we have to load that instance, or we have to download that instance, because that is the core one. Okay, just hit on new service, then go for machine learning here. Then you have to create a machine learning instance. So this is just creating the machine learning instance. Once the machine learning instance is created, we would refresh the page. Yep. So maybe sometimes based on the locations, your instances would have been this thing. So it's better that you click on every instance, and then you click on every location, and then you will see which all instances you have to use. So we just installed the machine learning RX instance. So I'll be hitting on this, and then I will be saying associate service. So once the service is associated, just reload, and we get the name here, machine learning RX, and then hit create. Yep, we see it's associated. Kindly refresh the page if it's not showing anything. It takes a little bit time because it's all about cloud. So now we hit on get it, and then we have to, they are saying to add data sources. So as we have already loaded the advertisement.csv file, so we'll say select from project, and then we'll see data asset, we'll click on advertisement.csv, and we'll hit on select asset. So this is selecting the columns and everything. So now here it says what do you want to predict. So we will say we want to predict clicked on ad or not. So it automatically detected that it's a binary classification and all. Just if you want to tweak a little bit into hyperparameters and all, just hit on this. Then you see here we have a binary classification problem. Here we have the optimized metric, whether we want accuracy, ROC, AUC, average precision, recall, F1, log loss, whatever we want we can choose on ourselves, and then optimized algorithm selection. on which one do you want your algorithm to get selected, the one which is running very fast and giving you good result, or the one which is only giving you good result but takes a lot of time and all those things. So here the list of algorithms have been automatically selected by IBM Cloud only, like decision tree, extra trees, light GBM, logistic, random forest, snap decision tree, snap logistic, XDB and all. So here totally 8 pipelines are generated because 8 algorithms are selected. So this is all about the prediction setting. You can also choose on the data source where the pre-processing does. So to accelerate training, you can skip duplicate rows, it is automatically selected, and then subsample, you can sample up. This speeds up the result but may affect the accuracy. You can subsample rows. This basically helps when the data set is imbalanced. Then text feature engineering, it is automatically selected, and then the number of vectors per column is done. Final training data set is done, and the train data split, which we in sklearn do from sklearn.model selection import train test split. So that is the thing. 90% is the training data and 10% is the hold out data. And then just these are the few pages, these are the few times which we have to do, and then running the model, and these are all the experiment settings, and then we are all set to. In the last video we saw how the experimental settings could be tuned by the user itself and then can be modified according to the need which the user wants, and we can just select with which kind of classification or regression we are doing. We can select the optimization thing, and we can select the runtime of our model, like initial model tuning iterations is 10, feature engineering iterations, final model iterations, and everything. So these are all the few knobs and nodes where the user can tweak on according to his wish. If that is not the case, if we want to go with the default setting of IBM Cloud machine learning RX instance, then no need to tweak anything, just hit on run experiment. So I'm going by default settings, and just I just hit the run experiment thing, and then now the experiment will be running, and this will take a little bit time. Here we can see that pending advertisement advertising.csv starting the auto AI experiment, time elapsed 6 seconds. Here we can see that based on the we can see the progress map over here. The advertising.csv is just running, and we see the relationship map here, and this now the data source has been reading, so it just took 30 seconds for it to initialize, and then so so the train test split has been done. Training data is 90% and 10% is holdout data or the validation data. Then the algorithms are now about to come. When you hit on this point, the algorithm starts running. Now we see that selection of algorithms. As I said, when I hit this point, the algorithms get selected. So by default we had selected 8 algorithms, so there are 8 pipelines which are being made, and yeah, we see here. So this is pipeline 1, this is pipeline 2, LGBM classifier, this is pipeline 1, this is pipeline 2, this is pipeline 3, and many more pipelines will be coming in future. So here we see that pipeline 1 LGBM classifier gave us 96.2% of accuracy on cross validation, and we see that this text feature engineering has been done. The first round of feature engineering on text based features by transforming word to vectors before building pipelines. It's basically TF-IDF in case of natural language processing, and then hyperparameter optimization as the first process. These pipelines are dynamically built, and we see that these pipelines are now building up, and we can see that whenever there is a star over here, that means the pipeline is finalized. So pipeline 2 rank is 96.22222%, and build time was just 19 seconds. This is building. The hyperparameter tuning is running for it, that is why HPO is not mentioned here. TFE text feature engineering has been done. So this is star indicates that the rank by accuracy, so it will be in the decreasing order of their accuracies. Yep, so we see that there are 2 classifiers which are done. So over here FE is nothing but feature engineering, the final feature engineering performed on some pipelines. Yep. So this is pipeline 1, pipeline 2 and pipeline 3. So this gave 96.7% as the accuracy, and the cross validation has been going on. So you can see, you can click on pipeline comparison, you can click on this thing. You can see various kind of statistics which are been given here: area under ROC, AUC, log loss, F1 loss. Model name is P3, that is nothing but pipeline 3 which is currently running, that is why the star is there. Then P2, the pipeline 2. Just hover your mouse over here. We get the things getting known. Just hover over this line, we get the things. 96.22. See the next, the fifth pipeline just came up, and we see that the log loss of which pipeline is minimum. We see that P3 is hitting less, and P1, all of them are simultaneously occurring at crossing the point at 0.150. So basically in binary classification there is the binary cross entropy loss, that is the meaning of the log loss which we use in convolutional neural networks, right? So that is the log loss, and we see that the P1 pipeline, the loss was very much, and then the accuracy just fell down to 93%, and recall just went up to 93% and all. So accuracy was almost like 95.6 change. Pipeline 3 just gave us a good result. It hit the accuracy very much, and the loss was also very less, and F1 score precision and average precision and recall were fantastic of it. So if you just click on experiment settings, it is into the last stages when it is just running the XDB classifier, the last classifier. Already 7 pipelines have been completed. We see that the pipeline 3 gave us a very good result, as we saw over here. The pipeline 3, if we just hover onto this, the maximum result was that, and the log loss was also less. We see that the precision, recall, accuracy and ROC, AUC, everything was very well tuned in case of pipeline 3, and pipeline 3 was our LGBM classifier. So the status is just finishing up, and then the complete process will be finished within few seconds. Now it's almost time to do it. So we see different kinds of estimators and everything. No one better than pipeline 3 has given us a result yet. Pipeline 2, nope. Pipeline 3 just gave us very good result of 97% of accuracy, 96.66. it's almost 96.7%. and yep, experiment completed. That means the best result I think it's given by pipeline 3. No pipeline gave us very good result. So yep, it's a top performer, so it's given here. So we would basically select this LGBM classifier. We'll hit on this. We can by default see what is the cross validation score and everything. We can click on model information, feature summary, feature importances. Then we can go for confusion matrix. We can do some kind of precision recall stuff and model evaluation. You can play around with this. It gives a lot of statistics. And then when we hit on save as, we want this as it is. And then we want to create a machine learning model, not a notebook. We will be integrating this into a Streamlit application. That is why we'll choose the model. Then hit on create. So we were left in the last video where we just saw all of our pipelines. We compared all of our pipelines, and where we saw that LGBM classifier is a good choice. So now in order to deploy this model, what we need to do is we need to hit on save as. Then we'll say that the model name is add classification ML, and hit create button. The model has been created. Please wait a minute. Just hit on view in project. Once you go and hit in view in project, it will show the input and everything else. Then you have to create on promote to deployment space. Over here I have already created an advertisement classification space, so I'm just hitting on it. If you have not created an space, just hit on create a new deployment space. That's it, nothing else. I'm creating advertisement classification, and I'm selecting go to the model in the space after promoting it, and then I'll hit promote. So once I hit promote, this promotes my model to the deployment space. Okay, so Here is our model summary, and here are the model details, and then hit on new deployment. Click on line, say the deployment name as advertisement classification, serving name is not required, add a tag, nothing is required, just hit create. Just give the name of the model and then hit create, deployment. Okay, so the deployment is in progress. Once the progress is done, we can click on it and get the data of the deployment space. So it will take some time because it has to gather all the information and get it into progress. Yep, so we see that here we have the deployed option. Then we can just hit on this deployment and we should see the Python code now. Just hit on Python and here we get our thing, right? So this is a very important step. Now what you need to do is you just need to copy this and you need to paste it in a dummy file. You can create a dummy file or so, like stating like dummy.py, some dummy file you create which is of no use. Okay, this is saying it's already in use, so just create this file and then kind of just paste the code somewhere. You can even use notepad, no worries. You can even use notepad and formatize your code and store your code somewhere basically. Okay, so now one thing you can notice here, they are saying that you must manually set API key below using information retrieved from your IBM cloud account. So your API key is to be manually set. So what does this mean is the API key over here has not been given, so you have to manually set your API key. That is the meaning of them. So how to set the API key? So it's very simple. So we have to go to the starting page, cloud.ibm.com. So once we head on to cloud.ibm.com, we redirect to the dashboard page. Now what we need to do is you need to go to manage, you need to go to access IAM. Once you go to identity and access management, you have to go to the API key. You have to go to the API key, then you have to hit on create an IBM cloud API key, give a name advertisement API and then hit create. Once you create, you see the API key over here. You can copy it or you can download it, it's your wish. So if you download it, it will get downloaded in the JSON format. If you just copy it, you copy the API key and then paste it over here. You just backspace the things and then hit it, and here we have our API key set. Okay, so this is all about in this video. We'll see how to set up the entire thing in the next video coming up. Alright, so in the last video we saw how we have to download the API key, and then we saw that we deployed our machine learning model, that is LGBM classifier, to our Watson cloud service. So now we have to use them. So we downloaded the credentials from there and we have stored it over here. So what we have to do now is simply we have to integrate them in a form of a Streamlit app, which looks something like this. This is the Streamlit app, and this is a very simple, straightforward, responsive form. If you can inspect and you can check how the form is, it is purely responsive and everything looks fine here. So we have to make this settings. So the first things first, what we need to do is just copy from line number 4 to line number 10. Just copy them and then paste it over here. Paste it over here as it is till line number 19. After you paste it, this is just a sample input which I took from the CSV in order to check whether the application is working or not. You can just you can also use it or you can use some other things, it's up to you. and then we import our dependencies here. First we import the Streamlit. If you are not having Streamlit, just on the terminal just hit pip install Streamlit, pip install Streamlit. If Streamlit is not present, then just hit pip install Streamlit and hit enter. This will download the Streamlit package in it, and then numpy as np and pandas as pd. Pandas as such is not required. Numpy may be required. Let's see. And requests comes from this only, so we have to download requests as well. Okay, so till header we are just copying code from the pre-written code which we copied from the IBM Watson service. Then we set our title, st.title, that is nothing but title of our web page, which is advertisement success prediction. Right, now comes the setting up the form. So as we see that the input is all about is all numeric, almost every part is numeric. So we will say, if it's a numeric input, then we will say st.number input, enter your daily time, st.number input, enter your age, st.number input, enter your area income, st.number input, enter your daily internet use. And if it's a categorical variable or a textual variable, we say that text input, st.text input, enter advertisement topic line, st.text input, enter city. And then if it's a choice which we have to make, then we will say that st.select box, enter gender, that is male and female. And yep, if it's a text, then we say text input. If it's a number or a floating point decimal, we say number input. If we want to select from any choice, basically select boxes we use when we are having ordinal variables. So your male and female are ordinal variables, so we use st.select box. Here they are not ordinal variables because we just have two choices, either male or female. We can select anyone. Okay, so we select male and female. Note that there is no require of doing any pre-processing of the data here, because everything is done in the pipeline which is running in IBM Watson. So you just need to type in the code, type in the data type as it is, which is given in the your CSV file. No need to do any kind of update, just simply do it, because all the pre-processing and stuff is done at the IBM cloud service. Now the main logic of the code, linking the code, the data filled in the form to the IBM Watson Studio. So now we'll create a button which is nothing but this button, which is a predict button here. So now if st.button predict, now over here this is very important now. So as we all saw in the basic supervised machine learning algorithms as well, we send the data in form of numpy arrays or 2D arrays, right? So the same thing, the input is sent in form of 2D array, which is over here. So all this information is stored. These are all the variables which we just declared above. So if you just observe daily time, age, area, income, daily to use, everything is declared above, and the data is stored there, and we create a 2D list of input features. Now over here, for payload scoring, what we do is we create a JSON file. JSON is nothing but JavaScript object notation. In Python language, it is nothing but a nested dictionary. Okay, so what it does is this is a way to interact with the Watson service in the form, the data is always given in form of JSON format to the Watson service, because it is running on cloud, and when it's running on cloud or web, we need to pass the data in form of JSON so that the extraction is done there. So input data is a key, and to that key there is a value list. So we say that and that value list is also nested inside a dictionary, so which has fields as a key. So the fields is nothing but these things which we declared here: daily time, age, area, income, and all. So we declare the same thing: daily time, age, area, income. The same thing which we declared over here is declared over here, but the only difference is it's into double quotes. That's it. And values is nothing but the input features. This is nothing but the input feature itself. Basically these are all the variables, and the data of the variables is stored inside this input features. So the fields are these, and corresponding to the fields, these are the values. That is the meaning of the payload scoring. right? So now the response scoring. What does the response scoring do? It hits a post request to the service which we called. So now this thing is very important over here. Just see this. We just copied this part, and we copied and we pasted over here. Input feature, payload scoring and response scoring. Payload scoring is a method where we just given the data, where we just given the input to the model which we have to give, like fields, area of input fields, values, area of values to be scored, another area of values to be scored, all those. I just explained it now that input, the fields is nothing but all the variable names in quotes, and then the values of those variable names are nothing but they're stored in the input features which we saw over here. So once the input features and payload scoring is done, we hit a post request now. You must be familiar in the Flask app where we send request.posts. The same thing is over here. We send a post request to this URL. Where did we get this URL? We got this URL from the IBM Watson service page. If we remember, we got this URL from here. We see that request.post get version and this big URL. We just simply copied and just pasted here. So JSON, as I said, that as the service is on web, we have to pass the data, or the data pipeline is been made in form of JSON. So the data pipeline accepts the data in form of JSON. So that is why JSON object is nothing but the payload scoring. The payload scoring is itself a JSON. We can see that the dictionary which is nested inside another dictionary. And then the headers is equals to authorization bearer plus ML token. No need to worry about the ML token. It's already been taken care here. ML token is over here. Token response.json access token and its internal mechanism. No need to worry about it. Just make sure that the payload scoring feature is properly made. Payload scoring feature must be properly made, and then everything is all ready. Then we say print response scoring.json. I'll say how I'll show you how this thing looks like. See, the scoring response is given in this format: predictions, fields, prediction, probability, values, and this whole big string is nothing but this response scoring.json. Okay, the post request goes to the IBM cloud. The IBM cloud service takes in the input and processes it and returns the output in the form of a JSON file which is stored in this response scoring. So when you print response.json, you get a JSON file like this, which is a dictionary, nested dictionary. So over here we have this thing. In order to get the values, in order to get this thing is the prediction, right? The prediction is this thing, 0.9999999% is the prediction, and this is the class value basically. Okay. So predictions, we taken the prediction, we taken 0 is nothing but this part, this list is nothing but represents 0, and from that we take the values. After we consider the values, the thing looks like we are just using this one, and from that we select the 0th index, that is this, and from that we select first one, that is this, and from that we select 0, that is this. So it's all basically nesting of indexes. You can just play around with this. If you are facing any kind of problem, what you need to do is very simple. Just hit print and just print ans of 0. You just do some random kind of indexing here. You will see the responses, and then you can automatically figure how to get it. It's very simple. It's no big rocket science here. Then if final probability is greater than 50, then we will say based on the above scores the user viewed the advertisement. We set our threshold to be 0.5, and if it is not the case, then the user did not view the advertisement. Now if there is any kind of exceptions which is occurring during this, exceptions may be a bad request. That means this request.posts over here may sometime go wrong, or basically the IBM cloud service may not respond quickly. So it throws an exception over there. So in order to handle all the exceptions, we just write a try except block so that our website doesn't crashes. It handles all the exceptions and everything becomes stable there. So we say accept st.markdown, hang on, might be some mistake in the input, do check it again. So you can keep any kind of text whichever you are seeming, whichever you are likely to be. And then this is all about how the Streamlit app would look like when you hit on predict. It is running, and it will show out the output that based on the above factors, the user did not view the advertisement. You can manually type in anything over here. You can review the data set description over here, and then you can just go through all the details whatever is written, and then you can make sure that everything is working fine. So yes, this is all about the Streamlit app which we made. In the next video we'll see how to deploy this on Heroku. Thank you. Hello. So in the previous video I stated that we would be deploying this application onto Heroku Cloud. This application uses IBM Watson service, and then it is an auto AI experiment which is running at the background, and we are hitting the input to this URL which we got it from the IBM Watson service, that is from this one, that is we got it from this one. So for every user we get every user gets this as a unique one, so kindly follow the steps and procedures which were mentioned in the previous video. So now for deploying this application on Heroku, as this is a Streamlit app, we would be requiring 3 extra files here. One is the proc file. Proc file is the one which guides the Heroku from where the execution of the entire project must start from. So it's a web based application, so that is why it's known as web. And then sh is nothing but a shell, and there is a shell file which is known as a setup.sh file, which I will say, and then and it's this logical and then Streamlit run app.py. So basically it says that, hey Heroku Cloud, just this is a web-based application. So this proc file is saying to the Heroku Cloud service that, hey, this is a web-based application which is having a setup file, so kindly go through that setup file first, and then do all the build over there first. Once the build over setup file is done, then go for the Streamlit run app.py. That means you have installed all your dependencies, and then now you are all ready to run the application on your cloud machine. So this is what this proc file is all about. It just gives the starting instruction to the Heroku Cloud computing engine, stating that you have to start from this setup file, and then after setting all the instructions, downloading all the packages from the setup file, you have to run the Streamlit app. So we have this requirements.txt which says that what all kind of requirements are required in order to what are all the packages which we used in this app.py. So if we just without writing the requirements, if we just import this will be a build error. So we have to make sure that we are using this. Basically we are not using anywhere NumPy and Panda, so it is not required. I just wrote it for in case if we need some kind of help from these packages, but you can ignore them. Yep, you have to mention requests here. I didn't mention the request in the requirement.txt, so we have to mention requests, otherwise it would not get installed. So request is a very important library here, and we have to save this, and requests is done. So we have Streamlit, sklearn, IBM Watson and requests. So we're already with the requirements.txt file, and then in the setup.sh file, which is a shell file, we make all this make directory. This is all Linux commands. If you're interested into it, you can simply browse on internet and you get all the requirements or all the commands which you need to kind of integrate into your Streamlit app. So these all you will get on the internet. No need to learn all these commands. They are different commands. Sometimes some commands work, sometimes some commands don't work. So this setup.sh file works always for me, so I prefer to use this. Then we are all set. Now we need to open our Heroku account and start making the builds here. So how to open the Heroku? If you're new to Heroku account, just hit up, if you're having an account in Heroku Cloud, just hit on your email address and password and then hit login. If you are new, then hit on sign up, and then this will be redirected you to the sign up page where you can give your credentials and then create a free account. It will ask for email verification. A link would be sent over there. You can verify your email and then everything's set up. So once if you fill in the credentials and everything is all set, the portfolio would look like something like this. So now over here, as I'm having one service already running, we can run 4 services on Heroku Cloud for free. If you're out of it, then if you're trying to deploy more than 4, then you have to purchase the premium pack, or you can delete any one of them so that you can make it out 4. So now here I will hit on create new and then create new app. I will give the app name as advertisement classification. I have given this name. This name is available, so it showed me this. Sometimes the names are not available. It says that please select another name. This is the user has to take care of. Then hit create app. Once create app is done, so we now head on to the deploy page. Over here we can use command line interface of Heroku, or we can use GitHub, or we can use container registry. For Streamlit apps, I personally use the command line interface because I have this shell script which has to be executed. So I feel better like if I use a command line interface, I will be in short of errors. You can even use GitHub. It's not a thumb rule that you have to always use CLI. You can use GitHub as well. But I am used to use CLI, so I'm using CLI here. So first if your machine is having CLI or not, you can just check it like this. Click on Heroku and then hit enter. If you get something like this, that means the CLI is there. That means the CLI is installed in your machine. If it's not, then you can simply hit on Heroku CLI and then install the command line interface software from here. You can just based on your machine. If it's a 64-bit machine, hit 64-bit. If it's 32-bit machine, hit 32-bit. If you're using on Ubuntu 16, you can follow this code. And everything is self-explanatory in this. They have explained it very good, in a very good manner. So now we have to simply copy all this code and then paste it on this terminal because I have Heroku. So now just press any key, you'll be redirected, and this will be opening, and then simply hit login. So once you hit login, it shows a message that okay, so and so email ID is logged in. Now what we need to do is we need to copy the text here, commands here. So basically don't copy the first command because you're already inside a directory, so better avoid the first. Git init is nothing but initializing an empty repository. You see that when you initialize this, everything becomes green. That means the branch has now become master. Initially it was not master, now it became master. Okay, then hit Heroku get remote, copy this, paste, enter. It creates a git object. Copy, enter. Copy, enter. Everything is now set. Now only one command is left. This will just push your repository to Heroku Cloud. Simply git push Heroku master. It's importing all the dependencies which we mentioned in the requirements. See, installing requirements with pip. So this will take a little bit time, but that's fine. Yep, everything seems to be installed. Installing collected packages. Just 2 minutes, hardly 2 minutes, then the deployment will be done. Heroku Cloud provides a fast deployment. Maybe because we are using a very as we are using IBM Watson service, the model is deployed on IBM Watson and it takes a little bit time because we are making asynchronous requests here. So that is the reason. One thing to notice, very important thing to notice, this IBM Watson thing is temporary. So maybe if you are able to access your machine learning instances for almost like 5 to 6 days, but after 7 days there might be a possibility that your Watson service has been crashed. The Watson service crashes because IBM asks for credit information. As I already mentioned in the starting video, that free trial is only available for 30 days, and then after that you have to pay bucks for IBM so that your services run on. So that is a little bit of negative side of them, and obviously they make business out of it, so we have to be they also have their own ideology into it. So no worries, if you want, if your system is getting down, what you just need to do is, in that case, you create another machine learning and you create another Watson account. Okay, follow the same procedure which I say, described in the other videos, and then the changes would be just in API key and the API key and this thing, the URL. These things will be changed, other things will be remaining the same. So now what you have to do is, you have to update in this app.py, and then there is one command on Heroku which is over here, and follow the same kind of approach, and I think it would be all it. So yep, we see that this is being released here. So let's just open this. Yep, so a Streamlit app is getting opened and is into production. Great. So now you can hit on settings, and you can change it to black mode or dark mode, whatever kind of mode you are willing to, and then just hit enter your credentials, and that's it. It would be all. I would be filling in some details. Enter your age. Let my age be 35. Area of income is this thing. Copy, paste. Daily internet use 256.09. Copy, paste. The tagline of the advertisement, copy, paste. City, copy, paste. And gender is female, because over here 0 represents female and 1 represents male. Tunisia, copy and paste. Timestamp was not required that much. You could have omitted this in the IBM Watson thing, but it's fine. Paste, and then when you hit predict, yep, we get the result as, based on the above factors, the user did not view the advertisement. So it's working completely fine, and this is how we deploy, this is how we make a blend of IBM Watson service and Heroku Cloud and deploy on the Heroku. And this is a very simple, short and sweet supervised learning application, and it's very simple to deploy everything once everything is very clear under this.